Hello, geometry students, and welcome to lesson 6.6. We're going to look at the conditions of special parallelograms. So in example 1, let's see, given the information about the diagonals, can we classify it? Okay, so we're given that AC is perpendicular to BD. Okay, so what else can we conclude? So think about that for a minute, maybe pause the video. So what can we conclude? The diagonals of a parallelogram, they bisect each other, right? And we are told that it is a parallelogram. So we know that AE is congruent to CE, and we know that DE is congruent to BE. We also know that at E, we have linear pairs, we have vertical angles. So when we have one right angle, we have four right angles. Therefore, by SAS, we have congruent triangles. So we know that AB is congruent to CB, and AB is congruent to CB, I pointed to the wrong thing, and CD is congruent to AD. Okay, so since it's a parallelogram with four congruent sides, we know that it's a rhombus. Okay, try it number 1. If JHK and JGK are complementary, what else can you conclude about GHJK? So let me mark off those angles. So we have GHK, that's this angle, and JGK, this angle here. Okay, so if those are complementary, what else can we conclude? Well, because we have the parallels, we also know we have congruent alternate interiors. Right? So I know that these angles are congruent, which means that these angles are complementary as well, which means I have a right angle. And if I have a right angle where my diagonals meet in a parallelogram, then I can conclude that it's a rhombus. So that brings us to theorem 619, which says that the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Theorem 620, if a diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus. So in example, in example 2, we're asked to write a proof of the parallelogram diagonal bisector theorem. So we're given that FGHJ is a parallelogram with angle 1 congruent to angle 2 and angle 3 congruent to angle 4. Okay, so I did this one in paragraph style. So go ahead and pause the video, give this an attempt, and when you're done, come back and we'll compare ideas. Okay, so here's my version of the proof. You can read through this, and if you have any questions about it, ask in class. So go ahead and pause the video, read through the proof, and let me know if you have questions about it. Okay, try it number 2. So refer to figure FGHJ and use the properties of parallelograms to show that if 1 is congruent to 2 and 3 is congruent to 4, then the 4 angles are congruent. So go ahead and pause the video again. Think about how you would show that all 4 angles, FGHJ, are all congruent. Come back when you're done and we'll compare ideas. Okay, so again, you can read through my solution. Let me know if you have any questions about it when we're in class. And if so, we'll go through it together. Example 3, using diagonals to identify rectangles. So Ashton measures the diagonals for his deck frame and finds that they are congruent. Will the deck be rectangular? Okay, so in the diagram, we can see that opposite sides are congruent, right? And to show that the structure is rectangular, we need to show that we have right angles. So the opposite sides and the diagonals are congruent. So we can split this into the two overlapping triangles. We're going to pull them apart, right? We've got ACD and we've got BDC. So they are congruent by SSS. So therefore, angle ADC is congruent to angle BCD. Now we know in a parallelogram that adjacent angles are supplementary. So if they're supplementary and congruent, they must be right angles. Therefore, this parallelogram is a rectangle. If the diagonals of any quadrilateral are congruent, is the quadrilateral a rectangle? Justify your answer. So pause the video, think about that for a minute, and then come back when you have an idea. Okay, so if it's just any quadrilateral, the answer is no, right? If the diagonals do not bisect each other, then the quadrilateral is not a parallelogram, so it cannot be a rectangle. So if you're trying to think of an example, remember our isosceles trapezoid. That also has congruent diagonals, okay? And that is not even a parallelogram, much less a rectangle. Theorem 6-21. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. In example 4, can we conclude whether the parallelogram is a rhombus, a square, or a rectangle? So pause the video, look at the diagram, see what you think, and then come back when you've made a decision. Okay, so by SAS, or BD is a shared side, we know that these triangles are congruent, which then we can conclude that angle ADB is congruent to angle CBD or CDB by CPCTC. Diagonal BD bisects angle ABC and angle ADC. Did I say that? ABC and ADC. So parallelogram ABCD is a rhombus. Lots of letters going on here, this one. Okay. Example 4, can you conclude whether the parallelogram is a rhombus, a square, or a rectangle? So think about what's given here. If you need to, pause the video. Okay, so the diagonals are perpendicular. So PQRS is a rhombus. They are congruent, so it's a rectangle. Since it's both, it's the square. Try it 4A. So is the parallelogram a rhombus, a square, or a rectangle? So I'd like you to try this one, and then on the next one, also try it 4B and an additional example 4. And then come back when you're done and we'll compare solutions. Okay, for 4A, the parallelogram is a rectangle, right? Since it is a parallelogram, the diagonals bisect each other. Therefore, using the given information, because these have congruency markings, we know that that HK would be congruent to JG. Therefore, since it has congruent diagonals, it's a rectangle. For 4B, it is a rhombus. Opposite angles are congruent in a parallelogram. So if angle VWU is congruent to the 3 marked angles, since the diagonal bisects opposite angles in the parallelogram, we know that TUVW is a rhombus. For additional example 4, we know that all 4 sides are congruent because opposite sides are also all four sides are congruent because we know opposite sides are congruent. Right? So if we have two adjacent sides, and again, we're given that this is a parallelogram, we know that actually all four sides are congruent. Since the diagonals are congruent, because again, remember the diagonals bisect each other. So if these two segments are congruent, then the full lengths of the diagonals are congruent. Given that, it makes it a square. So again, don't go by what the figure actually looks like. You might be saying, well, they don't look like right angles. It's not going to be drawn to give away the shape. Okay, you have to go by the markings on the diagram. Example 5, we're given that STUV is a rhombus. So what are the values of x and y? So go ahead and try this example, okay, using the theorem that we talked about with the angles. And also just try it number 5 and additional example number 5. Try those and then come back when you're done. Okay, so hopefully for this one, you got 13 and 10. If you need to, pause the video and go through the solutions. For try it number 5, W would need to equal 13. And if you need to ask about that in class, then please do. For additional example 5, we want this figure to be a rhombus, which means x has to equal 5 and y has to equal 9. Again, pause the video and go through the solution if you need to. In example 6, so we have a kickball field with bases 60 feet apart. How can they verify that the field is a square? So we're given that opposite sides are congruent, or actually all sides are congruent. And so we know it's a parallelogram. We know even more than that it's a rhombus. So to determine whether or not if it's a square, we need to check those diagonals. So in this case, they measure the distance from home plate to second base and third base to first base. Then we could determine whether if it's a square or not. So try it number 6 and determine whether if this is a rhombus or not. And then come back when you're done. Okay, you should have found that the diagonals bisect each other. Okay, we can tell from the markings. So we know that it's a parallelogram. The measure of angle MRQ ends up equaling 90, right, when we subtract the angles from 180. So the diagonals are perpendicular. So if it's a parallelogram with perpendicular diagonals, we know it's a rhombus. So be sure to read through the concept summary. Okay, go back if you didn't already and make any marks next to any examples that you'd like to talk about in class. That concludes this lesson for 6-6. I hope you enjoyed it. Have a good day, and I will see you in class.